Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 2 on our project where we are connecting the most excellent Adafruit GPS, Ultimate GPS breakout board to our Beaglebone Black. If you were here with lesson number 1, and I hope you were, you learned how to get this thing set up, and we actually got it to the point that the GPS was spitting out NMEA sentences, and the Beaglebone Black was reading them in, and it was a little bit of tricky stuff in there. So if you have not done that lesson, make sure that you go back and start with that lesson. In today's lesson, what we are going to do is we are going to learn how to start sending commands from the Beaglebone Black over to the Ultimate GPS. Now, I will tell you right up front that the Ultimate GPS is more of a talker than it is a listener, and so it is just normally sitting there spitting out NMEA sentences, and we're over here trying to catch them. But I am going to show you how in your configuration, in the top part of your program, you can actually configure the Ultimate GPS to do things a little bit more like you would like them to do. There's not a whole lot of things that you can do, but there are some things that you can adjust and change. We're going to show how, rather than having it give us all the NMEA sentences, have it give us just the 2 NMEA sentences that we need. And then we will also show you how you can change the baud rate, and we're also going to show you can change the rate at which the GPS is sending out the data. We still can't set up a client-server type relationship, but what we can do is we can get the GPS to behave just a little bit better. That's what we'll be doing in this lesson. Again, I strongly recommend that you go back and watch lesson number 1 if you have not seen it yet. Also, hooking the thing up, if you go to TopTechBoy.com and you go to excellent Beaglebone Black GPS tracker project, lesson number 1, you will see this chart that shows you how to hook it up. We've got the GPS, we've got the Beaglebone Black, and we show you the pin connections. Understand that the Adafruit Ultimate GPS does have a 3.3 volt regulator on board, so you can safely hook the GPS up to the 5 volt power supply on the Beaglebone Black. Okay, I'm going to assume that you have this set up at this point because you went through lesson 1. So what we need to do is we need to come up and get ready and start writing some code. And so let me get this ready here. Okay, and I apologize, I've had to make my font a little bit smaller on this lesson, and the reason for that is that there's going to be some long lines, and I don't want the line to run off the end of the screen because that puts some strange characters on the screen for you. And just for clarity, I want all the lines to fit on, all the text to fit on one line as I'm typing. And so you might want to watch this full screen because this is going to be a tad bit small for you today. I try to keep that font big so you can see it nice and well, but today it might be a tad bit small. Also, I am debugging and trying to get this software working and stuff along with you, and so we are going to be using the GPS and the Beaglebone here on the tabletop inside, so we will not be able to get a fix. We can fully develop this part of the code and we can test it, but we're not going to actually be getting latitude and longitude. We will be getting the NMEA sentences, but they'll be empty, but still we can do everything that we need to do for today. All right, are we ready to go? Okay, you logged on. We want to see where we are. Okay. See where we are, PWD. We're in the roots, so we need to go down to my Python. I'm going to change directory. Hopefully you've made this directory already. If you haven't, go back and watch some other lessons, earlier lessons. My Python. And then we're going to edit a file, create and edit a file. We are going to call it we're going to use Nano to edit our file, and we will call it GPS command because we're going to be showing you how to send commands to the GPS. Look at that, we got a fresh new file to edit. What is the first thing that we want to do? Well, we're going to have to import some libraries. So we're going to import serial. That's the PySerial library. It should already be there on your Beaglebone Black if you have the latest operating system. So we're going to import serial. We're going to import the Adafruit library. So Adafruit underscore BBIO dot UART as UART. If you were here with us in the lesson number, you see that this UART is the library that will allow us to talk over the serial pins. Go back and watch that lesson. It explains everything. Okay, we need to from time import sleep because we're going to be putting some delays in there, and this is the easiest way to do it with the handy sleep command. Now we need to turn on our UART library. So we are going to do UART dot setup, and then which pins are we using? Which setup are we using? We're using UART1. Again, this is all explained in the first lesson, so this should be a review for you. But we're turning on those UART1 pins, which are the pins that we're hooked up to down here. Now we've got the GPS side of things set up. We got to set up the serial port over on the Beaglebone Black. So we will create a serial object that we're going to call SER for serial. And that's going to be equal to serial.serial. Now look at this. Small s on the first serial, large S on the second serial. Now we have to tell it where it is. It is in single quotes /DEV/TTY. Listen to me closely. Capital O. Not a zero. Capital O. Uppercase O. Uppercase O. Uppercase letter O. Then the number 1. Now we set our baud rate 9600. That looks good. That should set up a most excellent communication between the UART on the UART on the to talk to the GPS, and then we actually open up the serial port there. Okay, I think that should be good. We're going to do something a little bit new here today in our Python programming. We're going to, I think for the first time, create a class. And what a class is, it's, you kind of think you've got variables for numbers and you've got functions that you can do, math or do different functions in. Well, so you got data structures and you got functions. A class is something that combines data structures and functions, and it's very, very useful. Once you create a class, then you can create objects of that type of class. And so we are going to create a class to initialize our GPS. So what should we call it? We'll call it GPS. And as we come in later, we'll start building this class up in later lessons. It will be sort of the class that does all the functionality. But for right now, the only thing that we're going to really do in here is put some setup variables in. The first thing that we need to do is define a function, and it's a very special function in a class. You can make any types of functions that you want in a class, but there's a very special one called the init function. And what it does is it runs automatically when you create an object of the class GPS. So down here where we create our GPS object, it will come in and automatically run this init function. And we don't have to call the init function, it will just do it for us. So that's quite handy, but we got to define it. So define, we're defining a function. 2 underscores, 2 underscore, watch this, 1, 2. And then what do we call it? Init. And then 2 more underscores, underscore, underscore, boom. That should define it. What parameters do we want to pass to it? Well, you always pass self to it, or I always do. Okay, and I'm not going to explain how this works. It's just easier to see how it works, and you'll see later how we start using this, this concept of self. But for right now, just do it. Okay, now, what we are going to need is we are going to need a long list of variables. You can type them in by yourself, but I'm not going to sit and type them in because I would make so many mistakes. We would be here all day. So what am I going to do? I'm going to go ahead and save this. So I'm going to Control X. And let me explain what I'm doing. I have not figured out a way to copy. I'm running the VNC server, the type VNC server. So I'm remotely logging into the Beaglebone. I am not able to figure out copy from Windows, which I'm on right here, and paste into this window. So I'm going to do something kind of kludgy here, but okay. I said Control X, yes, I want to save the changes. Yes, that's where I want to change it. Okay, and now I'm going to go to PuTTY. Go back and look at our earlier lessons. Search toptechboy.com if you haven't installed PuTTY yet. But I call PuTTY up. I'm going to PuTTY into it 10.1.15.25. You would use your IP address. This is my IP address. Don't use mine, use yours. Okay. I'm going to log in as root. And you can see now that I'm on here. I'm going to change directory down to my Python. And now I'm going to nano gps.command. Okay. Ooh, that doesn't have my old stuff in it. Let's see here. Oh yeah, I typed it in wrong. Sorry. It was nano GPS command, no dot. So I'm putting nano GPS command. GPS is uppercase. Okay. Now when I come in here, you can see this stuff that we did before. Now I'm going to go over to the most excellent website, toptechboy.com. I'm going to go to Beaglebone Black Lesson 2, sending commands to the GPS module, and I'm going to come down here. Do not copy all the code. Okay, you just see that we've got the same thing that we've already done. Then on this define init, you get all of these variables that I set. Okay, all of those variables. Don't get down here where we write. I've got to explain that, but you just want to copy those variables. Okay, so I'm going to start here with the comment, and I'm going to go down last variable. I'm going to right mouse click and copy. With a little luck, come down to the next line. With a little luck, most of this will paste in, but we might have to kind of tweak it a little bit. But let's do a right mouse click, and boom, a lot of stuff came in there. I don't want that on there. That's nonsense. Okay, so I got a little extra line. Okay, so now let's go up and see all the things that we got. Now I think what we probably need to do is make sure that our tabs are going to be set right. So I'm going to go all the way back, and you can see that did not go in right. Okay, you got to keep your alignment perfect. Python is very picky about this, so I'm going to tab twice, and then yeah, that looks like it's gonna work. So I probably won't have to do all those. Okay, so it did bring them in lined up. Okay, and so we look at all that. All right, so now I'm going to go back to something that's easier for you to look at. So I'm going to say Control X, yes, Y, and then Enter. Okay, I'm going to get out of this PuTTY nonsense, and I'm going to come back over here. I'm going to say nano GPS command, and boom, we have all those things and all those things that you are not going to have to type in now. And it looks like these might have just kind of run off the screen, but most of them you can see. When it runs off the end of the screen, it puts that $sign there showing you that there's more that you need to scroll to the right. The $sign is not really there. That's just telling you there's more stuff that's not showing on the screen right now. Okay, what do we need to do? Well, first of all, I need to come down, and this needs to be tabbed over where it's the same, because this is a clause that's underneath this function definition. So what are we going to do? I'm going to set up variables, and then you can send that variable name to the GPS, and then it will configure it in that way. Just because I set all these variables up doesn't mean that we want to send them all to the GPS. But if you have this thing, it's a nice little library, so if you want to change something, you just go back and just edit one line of the code. Well, I'm going to send this instead of sending this, or I'm going to send this instead of sending this. We're only going to actually send very few things. We will actually only send very few things. Let me get this nonsense out of the way for you. Okay, that looks good. Bring this back to the top. Okay. The way you configure the Adafruit GPS when you're doing it kind of in raw mode here without some sort of pre-written GPS library, there are commands that you write to this serial port that we set up that will talk over UART1. All right? The commands are cryptic, and you wouldn't want to be typing them in every time. So we're going to set up this little set of variables that make sense. So a couple of comments. Then what do I do here? I say update _10 10 underscore seconds. That is the command that will make the GPS report position once every 10 seconds. So that's very slow. And you can see that this is the command that you're setting this variable equal to. You're setting it up as this string $PMTK220, comma, looks like 10,000 star 2 upper F. Very important. The command has to end in /r/n. That's kind of like a new line carriage return. And if the GPS doesn't see the new line carriage return, it doesn't know that that command is ended. It took me a long time to figure this out. You have to explicitly put those in. What if we wanted to update every 5 seconds? I have a variable update underscore 5 underscore seconds, and it is this cryptic command. If you want to update once a second, you would send it this command. If you wanted to update it 5 times a second, which means every 200 milliseconds, you would send it this command. Okay, these are the commands that control how often the GPS reports. There's a second thing. How often does the GPS make a measurement? That's a separate set of commands. Now you got to get these things straight, because if you were saying make a measurement every 10 seconds but report 5 measurements a second, you're just going to be getting the same thing over and over until the 10 seconds are up, and then it makes the new measurement. Does it make sense? This is saying how often do you report. This is saying how often do you make a measurement. So would it not be logical to set those to the same value? I say yes. Okay, so this set of commands is going to define how quickly the GPS makes measurement. If I put measure MEAS underscore 10 underscore sec, it's equal to this command. Again, everything ends with the /r/n. I can have it make a measurement every 5 seconds. I can have it make a measurement every 1 second. I can have it make a measurement every 200 milliseconds. Okay? Now, with these commands, you can set the baud rate of the GPS. If you don't set a baud rate, it is going to be at 9600. These commands define what sentences are sent. If you give this command GPRMC only, which is this long string of nonsense, that will send you only the GPRMC sentence, which is a pretty good sentence. But for what I want to do, I really want 2 sentences, not all the 4 or the 5 that it spits out, but I want 2 sentences. And those 2 sentences are GPRMC underscore GPGGA is equal to this long string. If you want to go back and have it send all the sentences, you can send this command. Or if you want to send nothing at all and just have the GPS sit there quietly and do nothing, you would do this. So these are all of the commands, okay? And then what I think I'm going to do is I'm not going to do anything. I'm just going to have these sitting here. We'll come back in a minute and get that, get some actual commands where we're sending something. But right now what I want to do is I want to just go down now and create my GPS object. Okay, I want to create my GPS object. So what do I want to call my GPS object? I'm going to call it my GPS, like that. And what's it equal to? Well, I got to tell it, if it's an object, what class does it belong to? The class that it belongs to is what we just set up, GPS. We've got to do an open, close, and a colon. When I create this my GPS object, it's going to come up here to GPS, and it's going to run this init routine. This init routine is not going to do anything because it's just setting up variables. I didn't actually write anything. Now what I want to do is I want to remember that the GPS just sits and vomits out data. Well, the problem is it's unclear. It's at least hard for me to know what's happening. If I'm not reading from that buffer, that input buffer fills up. And when it fills up, then I don't know if it's overriding stuff, or I don't know if it's just ignoring the new stuff coming in. I don't know how that works. But what I know I'm going to do is I am going to clear out this serial monitor, because there could be a lot of trash in it or a lot of old data. So I'm going to say serial or SER flush capital I, input, serial flush input, okay? That's going to clear the input buffer. Now, the odd thing that I've seen is sometimes when I do that, as I'm clearing it, a new sentence is coming in and I get like a partial sentence. So what I have found that works, and if you knew what you were doing, you would probably have a better way to do it than this. I need to do it twice to make sure that I get out what was there and any partial thing that's coming in. I do it twice, and that works. Now I'm going to read the data. Well, what do I want to do? What did I forget to do? Right here, you remember in the Arduino it gives you the void loop. Here we don't have a loop, so I need to make a while. One is always 1, so this is going to loop forever. But now those need to be tabbed in. Okay. Now what do I need to do? Well, I just cleared all the data out. Might be a little bit of time before the next data comes in, so what do I need to do? I need to wait for data. So I say while serial.in waiting equals 0. What does that mean? If serial in waiting equals 0, that means there's no data. If there's no data, what do I want to do? I want to pass. I want to do absolutely nothing. So this will sit and loop as long as there is no data. As long as serial in waiting is 0, it's just going to sit and loop. But then when there is data, serial in waiting is not equals 0, and so it'll drop out, and then it will start executing here. Well, what do I want to do? I'm going to just say NMEA. I'm going to get 2 NMEA sentences. NMEA1 is equal to, let's see. No, you know what I'm going to do? I'm just going to sit and read in loops. I'm going to say NMEA is equal to serial.read line, like that, and then print NMEA. So this is just going to sit, and this thing is vomiting out data, and then this is just going to be sucking it in and printing it. And so this up here hasn't done anything at this point. I'm just getting it set up, and then we'll come in and we'll start building it. But I just want to get to the point that I'm talking to the thing. So what do? I do a Control X, and then yes, GPS command. You know what I'm going to do? I didn't put my .py on there, so I'm going to move GPS.command to GPS.command.py. So I'll have that. This is how you rename. You do a move. It moves it from one name to another name. Ooh. Oh, I keep putting that darn dot in there. There is no dot. You guys are yelling at me, I know. Somebody left a comment that they wanted shout-o-vision because they were yelling at me as I am making these ridiculous mistakes. Okay, now let's do a ls. And look at that, we got GPS command.py. So now I am going to Python GPS.command.py. I keep putting that, no dot, command.py. Okay, let's see what happens. What? Oh. Okay, no colon when you call it, only when you make it. So let's see if we can get back there. Nano.py. Okay, when I make something like GPS, when I make a class, I put a colon because that then creates this clause down here. Okay, but when you create your object, that's not creating a clause. That is just creating an object, and so it needs to be like that. I'm sorry. Control X, yes, or Y, and then enter. Okay, let's try it again. Ooh, I am putting colons like a crazy man. Were you guys yelling at me for that? I hope so. Look at that. No there, because there's no clause. There's no clause. That's just a command. This is a clause. That belongs there. So Control X, Y, and then enter. All right, let's run it now. Python GPS command.py. Okay, look at this. We are sitting there and we are reading NMEA sentences like a crazy person. So this thing is sitting there spitting them out, and we're just sitting here reading them in. I am curious. I thought I saw an error up there. Let's look and see. Control C will make it stop. And I'll try to Control C again and see if I can catch that error. Okay, no error that time. Let me try it again, Control C. No error. Maybe I just imagined it. But you'll see that it's just spitting out all of those NMEA sentences. They're empty because I don't have a fix, and it's just sitting there spitting them all out at all the default values of the GPS. Okay, let me Control C to stop there, and let's go back and let's start now sending it some commands. Control C. I need to do a nano GPS command .py, like that. Okay, we are editing things now. Also notice when you put the, I just see this when I put the .py suffix, it starts giving you a little bit of formatting color there. So that's another good reason to use the .py. Okay, so we set up all these variables. We know the things that we might want, but we never spoke to the Adafruit GPS about it. So let's see if we can send a few commands. Let me see one that I might want to do. Let's say that I want to make it go as slow as possible. Okay, and so I'm going to do a serial.write. Okay, and then we are going to do, and I don't know if I can copy and paste, but I will see if I can. Let's say that we want to make a measurement every 10 seconds. So we're going to say copy, Control V. I know what I did wrong. I didn't. And there is no telling where I just wrote that. Somewhere in there is going to be, because I think I did a Control V, and so somewhere in there is going to be that variable in a place that I don't want it. So when we run it, we'll find out where it went. Okay, so there, Control V. Okay, maybe it doesn't want to. Okay, it wants to right mouse click and paste, and then it went down there. Okay, got to show where I am. Right mouse click and paste. I could have typed it in easier than that. Okay, very important. When you talk to the Adafruit, it takes a while for it to think about it. So after you write that, we need to do a sleep for 1 second. Maybe it doesn't need to be that long, but I know that 1 second works. And if we're going to get an update every 10 seconds, it would probably make sense for it to operate to make measurements at the same rate. And so where was that? Okay, that was this one. Okay, this is how often it reports. This is how often it makes a measurement. Copy. Right mouse click, paste. Okay. Again, we're going to sleep for 1. And then I'm going to try to start. That should work. Okay, so that should slow it way down. That should slow it way down. Control X, Y, and enter. Okay, I think this is going to work. Okay, it's initializing now. And is it going to come back to life? Okay, there it goes. You see it's waiting, 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 waiting. Okay, that sounds like that's somewhere around 10 seconds. You can see that once it sends all the NMEA sentences, and then it rests for about 10 seconds. Then it sent all the NMEA sentences, now it's going to rest for about 10 seconds. So you see, we really, really, really slowed that thing down. We really, really, really slowed it down. Okay, that looks really good. we sent our first command. So let's Control C to get this to stop. Let's go back and edit it again. So you could see that with this command and this command, we made it go real slow. Let's do a 5-second update rate. So if we're going to do that, we need to come down here, and we need to update both of those commands. We're going to say 5 and 5, okay, like that, because those were this one and this one. Okay, so that should make it go faster, but it's still going to be going pretty slow. Also, what I want to do here, I should just put a print and then say GPS initialized. So if it hangs in there, we'll kind of know whether it ever got through the initialization or not. Control X, Y, enter. All right, let's try it again. Python GPS command. The suspense build. Okay, look at that. It's initialized and now it's waiting for the data. So it initialized pretty quick. There was just the 2 seconds. But then it's waiting for the first group of sentences, and then they came through, and then there's the next group that came through. Let's look. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think that's operating at about like what we wanted. Okay, Control X, Control C. Okay, Python GPS commands. We want a nano GPS commands. You can imagine we could go in and make it run faster and faster. If you try to make it run too fast, it can't print fast enough. It's sending data in the print statement, slows it up, and so I don't want to try to just go run it full blast on this. But you saw we were still getting a lot of sentences that we did not want. So we gave it the serial write update at 5 seconds. Okay. Then we told it to measure at 5 seconds. That looks good. Let's tell it to stop sending us all that nonsense. Okay. What I want is serial.write. So again, over that serial port, we're writing to the Adafruit GPS. I'm going to do, let's just get the one sentence, the GPRMC only. Okay. So I'm going to not try to copy and paste GPRMC underscore only, like such. Okay. What do? We give it time to think, so we sleep for a second. It'll be a little slower this time to initialize. But this time, I think that we will have only the GPRMC. And let me make sure that, yeah, GPRMC underscore only, GPRMC underscore only. We should just be getting that one sentence. Now, if we see something besides that one, that means that it was still clogged up in the serial buffer, like the old data that had come in was still there before we gave it this command to only do these things. And so hopefully these serial flushes will take care of that. But if it doesn't, I might add another serial flush. So Control X, Y, enter. Let's run it. Python GPS command.py. It's initialized. We got an RMC, waiting 5 seconds. Got another RMC, waiting 5 seconds. Look at that! The old Adafruit taking orders from us now. Yeah, we're showing him who's boss here. Look at that. This is working. I feel good when I can get that GPS doing what I want to. Okay, let's Control C. Python GPS command.py. Nano is what we want to do. All right. Now, actually, what I really want to run fast. Okay? I really want to run fast. So what I want to set this at is my fastest rate is underscore 200, and it was milliseconds up there, MSEC. And this was 200 underscore milliseconds, like that. Okay, that looks good. And so this should run really fast. And so, yeah, this should run really fast. I want to do a Control X, Y, enter. All right, let's run this. Suspense builds. Yeah, look at that. I mean, it's just spewing out that data as fast as it's it's spewing out the data as fast as it can. And look, I'm only getting the GPRMC sentence. Okay, so I'm just getting the GPRMC sentence, and it is running as fast as it can there. So we're getting blocks of it, blocks of it. Okay, so let's control C. Okay, let's go back and work on it a little bit more. Nano GPS command.py. The truth is, as much as we love the GPRMC sentence, the truth is, for all the things I want to do, I also need the GPGGA. And it's like there's one, you can get almost one, but there's something like altitude or velocity. There's one of the ones that I want that's in the other sentence, because remember, I'm always looking towards using these things for high altitude ballooning. And for high altitude ballooning, I want latitude, I want longitude, I want altitude, and I want the downrange velocity. And so I need all those. To get the full set that I need both of these sentences. And we'll talk more about the details of the sentences later. Right now, we're just trying to get the GPS listening to us and sending us the commands we want. And so let's see if we can come down here and where was that? Okay, so here we wanted G, instead of only, it was GPGGA. And we're going to check that. GPGGA, yes. And so this should send us the two sentences we want. Now what we might have to do is, I am not sure if this can go fast enough, because it reads and it prints and it reads and it prints. And what I worry about is that when it's printing here, this actually is not going to work, because we're getting two NMEA sentences. We need to read one, read the other, and then print, because otherwise it's going to come up here and that second sentence is going to be coming in and it's going to flush it out. So when we're starting to fine-tune and tweak, what we are going to need to do is, we'll call this NMEA 1, NMEA 1, and then what we're going to want to do is NMEA 2 equals serial.readLine. Okay, don't do like read NMEA 1, print NMEA 1, read NMEA 2, print NMEA 2, because you could actually lose part of it in the time that it takes for the print statement. When it's throwing it at you as fast as it can, you've got to be catching it as fast as you can. So don't put anything in there that you don't need. But what I'll print is, now I'll print NMEA 1, and now I'll print NMEA 2. And then just to help us kind of see, I'll just put a print so we can sort of see a line between an empty line. Control X, enter, Y, and then enter. Okay, let's look at what happens this time. Python GPS.command. Okay, it's initializing. GPS is initialized, and look at that. It's just boom, 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 boom. It's sending us two sentences, and because we did the NMEA 1, NMEA 2, we are getting the two different types. If you're not careful with the way you set that up and you do that serial flush, you could be serial flushing your second NMEA sentence, and you would just get, like you would get the CC, CC, CC like that. You would not be getting the thing exactly like you want it. Okay, let me look here and see. That seems to be going real well. It is just flying through there. Everything is a complete sentence. I'm not getting any busted NMEA sentences. And playing with this Adafruit GPS, man, if you don't do this just right, it is very easy to get a busted NMEA sentence. Okay, I keep thinking I'm seeing something not good. So let me look here. As it's flying by, I'm imagining that I'm seeing something, yes. So we got one busted sentence here that came in without the $sign, and that would cause a problem when we were parsing it. So let's look and see if there's anything else that we can do here. Why would I be losing that $sign? I'm wondering if I'm flushing one too many times, that like it's already got that first $sign coming in and I flush that. So let's see if this works any better. Control X, Y, enter. You got to play around with this because, like I say, it's not a client-server relationship, so you've just got to get in sync with it. And you don't want to have busted NMEA sentences coming in, because then when we go in and parse the NMEA sentence, then it's gonna vomit on us if we're not careful. So. Okay, I'm getting an A and a C, and let's just watch it a while and see if we get anything that comes in that looks like it's not looking right. That's looking very good. So in this particular case, maybe just the one flush. You know, if I change the configuration, I do things differently. Sometimes I find that I need the 2 serial flushes, but in this particular case, maybe not. Okay, I'm getting an A and a C like clockwork. Nothing is broken. There are no problems. Everything looks most excellent. And so we would be getting very close to the point now of being able to go in and parse these things. Okay, but the way that we're doing this, if we're going to have a lot of different stuff going on, I mean, we're trying to test and shake this out and make sure that we got it working. Let's say you had a GPS and you had a pressure sensor and you had a 9-axis inertial system, and you're out there making 9-axis inertial measurements and you're doing all this stuff, and you just want to periodically come in and poll your position. You got to make sure that it still works if you only come ever once in a while to get a sentence. So let's do a Control C. So how would we simulate that? Well, let me come down here, and let's say that I was doing a whole bunch of other stuff. Well, how could I simulate a whole bunch of other stuff? Let's do a sleep for 10 seconds. Okay, what if I went away 10 seconds? Well, what's happening in that 10 seconds? It is still throwing data at me, but I'm not reading it. Okay, when I come up here, I'm going to flush the serial and then read. And in fact, I think a good practice up here would be for me to do some flushes up here, so that I leave that setup nice and clean with an, get rid of all the junk out of there before I even leave here. So I'm going to do serial dot flush input. I'm going to do 2 of them. Like that. Okay. Now, why do I still need to do this one? Because when I am in this loop, and when I'm waiting here, data is going to be coming in. And what can happen is, like, you'll have one NMEA sentence and then you'll have half of the next one or something. There's just goofy stuff that happens if you're sitting and just putting junk in the serial monitor without reading it. So now let's do a Control X, Y, and Enter. And let's see. We might still have to tweak our serial flushes. Python. Okay. Let's look. It initialized, and look, those first sentences were good. We got an A and a C, and now we're waiting. Let's see if the next set will come in as an A and a C. All eyes on the terminal window. Look at that. We got an A and a C. We got the $sign. It's a complete sentence. Nothing is breaking. Nothing is messing up. Okay, let's do a Control X or Control C. You got to play around with these, because this is like I say, it's awkward to make sure that everything is in sync. So I don't want to just do a really long wait. What if I did a shorter wait, more along the lines of how it's working? What if I did a wait of like half a second? Because you never know, right? When you go off and do something else, you don't know if you're going to be gone for a half a second or a tenth of a second or 100 seconds, because you won't want this to work no matter what program flow you put it into with your other sensors and the other things you're trying to do. Control X, Y, and Enter. Okay, we're going to run it. It's initialized, and we're getting a and a C, an A and a C, an A and a C. Okay, that is looking like it is working very well. Let's let it run a minute, make sure nothing goes wrong. Oops, we got a broken one there. So you see, when you have the delay kind of on the order of the amount of time that it takes to do the that it's sending them in, you can sort of come in the middle of one. And since we have 2 sentences, I want to do a serial flush input twice, because that should get rid of 2 sentences, and we should start clean here, I'm hoping. Control X, Y, and enter. Okay, I started out with 2 good ones. I'm getting the A and the C. Okay, so do you see, like, if it's already in the middle of sending these and then you start reading, things get goofed up, and so I clear it out twice and then I listen, which means I'll be starting right in sync with it. And so this looks like it's working. Let's watch it for 30 seconds or so and see if we have anything that's broken. In reality, you would want to run it a long time and really check it. And let's see, I got a bad one there, so let's Control X. Okay. Let's try it again. Okay, we got a bad one on the first one. Sometimes bad one on the first one, I would deal with that by just putting another, another serial flush up in the setup. But once it gets going, it looks like it's going to work. Okay. Another thing I think that will help is that we're saying send us the data as fast as you can. But okay, let's Control C. Part of the problem is, I believe, let me go back and edit it. We're saying send the data as fast as you can, but then we're using the slower baud rate. If we really want to run this fast, we ought to try to run at the higher baud rate, because that's snappier. It'll get it in, and it'll be less likely that we will have these broken sentences coming in. And like I say, if we could do a client-server relationship, we wouldn't have this problem. But there's not an easy way to do that with this. So we're just trying to kind of get our programs synchronized. How do we go to a faster baud rate? You got to do it really, really, really carefully. Like initially I thought, well, just come up here and set this at 57,600 and then come down here and send the command to make the GPS 57,600. But when the GPS boots up, it boots up at 9,600, so it wouldn't understand the command to change to 57,600 because it's on 9,600. So we've got to really think through this. All right. So what is the first thing that we want to do? We want to set it up here at 9,600. Okay, up here we are at 9,600. Now we want to tell it, as we're talking at 9,600, which is its lesson, we are going to do a serial dot write, and then what are we going to do? We're going to say baud 57,600. We're talking to the GPS, telling it this is where we're going to talk. Well, if we're going to do that, we better start talking at that. So the very next thing I've got to do is then do a serial baud rate, which is this baud rate here associated with serial. I can change that with serial.baud rate is equal to 57,600. Okay, Control X, Y, and enter. Now we're going to be talking faster. Let's see what happens. We are initializing, and we are doing absolutely nothing. We got, I know what happened. Control C. Hopefully you guys were yelling at me on this one. When we talk to the Adafruit, he's kind of slow. We got to give him a second to think about it. Okay, because he's off thinking about what did that guy just say, and then I'm shooting the next command at him and he's not ready for it yet. So now let's do Control. We put a pause in there. Control X, Y, and enter. All right, Python GPS.command. Is it going to hang on me again? No, there it goes. Okay, look, I got 2 good sentences. I'm getting an AC, AC, AC. You notice when it kicked off, there was a complete sentence when it kicked off. And now let's just watch it a while. I think that because we're saying go at the very highest rate of sending the data, we needed to be at this higher baud rate. And I think this is going to make it go without any broken sentences. This is looking good. Now what we can do is we can do error checking when we're actually running it, and if we get a bad sentence we can throw it out. But it's just better if you get this thing tweaked in where you're getting good sentences all the time. Look at that. I got an A, I got a C, I got an A, I got a C. It is really, really looking good. Let's run it again, make sure that it's going to do good. Okay. And pay attention to the first one that comes through. Okay, the first one that comes through, it should be about 3 seconds delay, so let's look. Okay, 1001, 1002, 1003, there it goes. And that first one off the bat was a good one. Okay, first one off the bat was a good one, and these are good ones. So we're running fast, and it's kind of goofy, but it's just like, I want it sitting there when I want data. I want to get out and get it and then go do my other business and do my other business when I want to get it and come back, because I don't want to get hung up in a slow GPS read cycle, because some of the other things that I might be doing are time sensitive. So I want it running as fast as it can, even though in the end I might just get a data point every second or so. Okay, let's do a Control C. Now that we made those changes, let's go in and make sure, okay, we're going to nano it. Let's make sure that this would work with longer delays. Okay, so let's say that I was out doing my business for 10 seconds and then came back, Control X, Y, Enter. Let's see if that's going to work. Python GPS command. Okay, look at that. I got an A and I got a C. I got good sentences, yes. Have a sip of tea while we're waiting for our next data point. And I got an A and a C. Okay, I got an A and a C. Okay, so I think we've got them talking to each other. We're sending commands to the Adafruit. He's listening, he's responding, he's coming back, and then he's giving us the data when we want it, how we want it. And now, like if I made this a subroutine, that whenever I wanted to do that read, I could just go out and do the read and get the data. What we will be doing in the next lesson is we will probably start moving more of this functionality up into that GPS class, so that you would actually call the functions under GPS class, and then you could more intuitively do it without having to do any of the goofy stuff down in the main part of the program. We're going to move all that up inside of that class. I think probably on the next one we will need to start parsing these GPSs. So when I come back for lesson number 3, what we'll do is we'll move the GPS outside so we can get a fix, and then we can start parsing these things. But I think we have made excellent progress in 2 lessons, okay? If you like this, give me a thumbs up, man. One of these. Give me one of these, okay? Think about sharing the lesson. Leave a comment. Leave feedback. I really appreciate your feedback. It lets me know that people are actually watching the videos. Paul McWhorter, TopTechBoy.com. We will talk to you guys later.